3.1 functions. So all of chapter 3 is about functions, and we're going to be doing quite a bit with them. So just a reminder what a function is no repeating x values. So what that means is for every output you have one input. A one-to-one function, it goes 1x goes to exactly 1y. So none of the y's can share anything. So there has to be 1x to 1y. So, for example 1, for the function f defined by f of x equals 2x squared minus 3x, evaluate f of 3, f of x plus f of 3, 3 f of x, negative f of x, and f of x plus 3. So the first one's very easy. All we're going to do is input 3 for our x, for every x we see. So we have our 3, and we're going to put it for every x we see. So f of 3 equals 2 times 3 squared minus 3 times x, which is 3. And then just work it out. So we have 2 times 9 minus 9. That's 18 minus 9. And we get f of 3 equals 9. So that's part A. Now part B wants us to do f of x plus f of 3. So f of x is just, it tells you, 2x squared minus 3x. And then we know f of 3, we just did it. F of 3 is 9. So what they want us to do is add that all together. So we have 2x squared minus 3x plus 9. That is from the f of 3. And the 2x squared minus 3x is from the f of x. And of course, simplify it if you can, but in this you don't need to factor anything, but combine like terms. Don't do anything more than that, just combine like terms. So f of x plus f of 3 equals 2x squared minus 3x plus 9. You notice how I'm writing this answer? I put f of x plus f of 3. In part A, I put f of 3. I have to tell, if you're reading this, you're telling the person what you did. You're telling them that you took f of x and you added it to f of 3. Alright, part C. Part C wants to do 3 f of x. So if you notice, f of x is the same thing as y. So it wants us to do 3 times our function, our y. So 3 f of x equals 3 times 2x squared minus 3x. So all we're doing is taking this 3 and multiplying it to the function. Now, since the function is 2x squared minus 3x, that's why we multiply the 3 out to it. So 3 f of x equals 6x squared minus 9x. And of course we can't combine any like terms, so we just leave it as is. Alright, part D. I'm going to do part D up here. Part D wants us to do f of negative x. So all we're going to do is switch our positive x, our x's, into the f of x equals 2x squared minus 3x with a negative x. So we have f of negative x equals 2 times x squared, so negative x squared minus 3 times x, which is negative x. And from here you just simplify. So f of negative x equals 2x squared plus 3x. Alright, part E. Part E wants us to do negative f of x. So you can think of negative f of x just like the 3 times f of x. We're going to put it on the outside. So negative f of x equals negative whatever the function is, 2x squared minus 3x. And then you distribute the negative. So negative f of x equals negative 2x squared plus 3x. Alright, part F, going all the way to F. F wants us to do, wrong color, f wants us to do f of x plus 3. So all we're going to do is put x plus 3 in for every x we see. So f of x plus 3 equals 2 times x squared, so that's the x plus 3 squared, minus 3x, which is x plus 3. And we need to FOIL our x plus 3. So we have 2 times x squared plus 6x plus 9 minus, distribute the 3, 3x minus 9, distribute the 2. We have 2x squared plus 12x plus 18 minus 3x minus 9 combined like terms. So we have f of x plus 3 equals 2x squared plus 9x plus 9. Alright, so finding the domain of the function. It's something that we've already done, but we always talk about it because domain is what you can put inside a function, and it gives you what you want out. So what you put in is very, very, very important. So if there is no fraction or radical, then your domain is all real numbers. If the equation has a fraction with a variable in the denominator, set the denominator equal to 0 and solve. We do this because we cannot have 0 in the denominator. If the equation is just a radical or a fraction with a radical in the denominator, set the radicand, that's the inside, greater than or equal to 0. We do this because we cannot have negative numbers inside the radical. If you have an equation with a fraction having a radical on top, the numerator, and a variable in the denominator, you set the radicand greater than or equal to 0 and set the denominator equal to 0. So we have an example of one of each. So the first one, part A, there is no radical, there is no fraction, so A is all real numbers. And to write that in interval notation, that's the infinity, negative infinity to positive infinity, or a line through it, or just say all real numbers. So part B, we have a fraction. And if we have a fraction, only a fraction, all we care about is the denominator because 0 can't be in the denominator. So what makes the denominator 0? You can either add 4 or factor. I'm going to factor. We have x plus 2 because that's a difference of 2 squares. So we have x equals negative 2 and x equals positive 2. So to write that in interval notation, it's actually harder. It's easier to write this in set builder notation. So in interval notation, let's do set builder first. That's x such that x cannot be positive negative 2. In interval notation, it's negative infinity to negative 2, and then 2 to infinity. And we use parentheses because we don't want those numbers in it. Alright, part C is just a radical. So what we're going to do is set the inside greater than or equal to 0 because you can't have a negative number. Negative numbers inside a radical produce imaginary numbers. So from here, we're just going to solve for t. We're going to subtract 4 to both sides. Negative 3t is greater than or equal to negative 4. Divide by negative 3. So we get t is greater than or equal to 4 over 3. Now to write this in set builder, it's x, or excuse me, t is the variable this time. I always do that. T such that t has to be greater than or equal to 4 over 3. And then if you want to write this in interval, nope, oh, nope, let's go back. I didn't catch it. Right here, we divided by a negative. If we divide by a negative, you gotta flip that sign. There we go. Glad I caught that. Alright, and then in set builder notation, since it has to be less than or equal to 4 over 3, that means only negative infinity. So we have negative infinity to positive 4 over 3. Part D, we have both. We have the radical on top, and then we have the variable in the denominator. So we need to do both things. X minus 5 equals 0. So add 5. We have x equals 5, and then we have 3x plus 12 is greater than or equal to 0. 3x is greater than or equal to negative 12, and then divide by 3. we get x is greater than or equal to -4. So we have two different numbers. We have greater than -4, and then x equals 5. So that does fall into those parameters together, so it makes sense. So to write this in set builder notation, it's x such that x cannot be 5, and x has to be greater than or equal to -4. Alright, so for the sum, difference, product, and quotients of two functions, so basically this is telling us to do PEMDAS on functions. So we have the sum, which is adding the two functions. So what you do is you just take f of x and g of x, or whatever the two functions are, and combine them. Same thing for difference, except you subtract them. The product you multiply, and quotient you divide. So for example 3, we're going to do each of these. We're going to add them, subtract them, multiply them, and divide them. But before we do, we need to determine the domain of each of these. You just have to do that, because you have to make sure that that domain stays true through the entire thing. So f of x domain, x can't be -2, because if you put -2 in there, you get 0. And then g of x domain, x cannot be 1, so if you put 1 in there, it equals to 0. So to write that, it's easier to write it in set builder notation. X such that x cannot be -2, and x cannot be 1. Now let's add these. So the first thing we want to do is add them. So f plus g of x equals f of x plus g of x. So all we're going to do is put f of x, which is 1 over x plus 2, and then we're going to add that to g of x, which is x minus 1. So since we're adding fractions, if you have trouble with adding fractions like this, because there's rational expressions, that means those variables on the bottom, there's a video for it, and that's in chapter 6. So it's adding and subtracting rational expressions. So all you need to do is get the common denominator, and 9 out of 10 times you just multiply them together. So we multiply the LCD out. Now we have x minus 1 over x minus 1, x plus 2, plus, multiply the x out, x squared plus 2x over x minus 1, x plus 2, and now you combine like terms. So we combine like terms, we get x squared plus 3x minus 1 over x minus 1, x plus 2. When you get to this point, you always need to try and simplify. So you want to try and factor if you can. In this case, we can't factor x squared plus 3x minus 1, so that is the answer to A. Now part B, we want to do the same exact thing, except we're subtracting. So for part B, we want to do f minus g of x. So that's f of x minus g of x. So we know f of x is 1 over x plus 2. And then we want to subtract that now from our g of x, which is x over x minus 1. So again, since we're subtracting, we need to get the LCD, but didn't we just already do it when we added it? The only thing that changes is the minus. So we have x minus 1 over x minus 1, x plus 2, minus x squared plus 2x over x minus 1, x plus 2. If we have that minus, though, we need to distribute it out to both. So now we have x minus 1 over x minus 1, x plus 2. And once you distribute it, you want to put everything on top. So negative times x squared is negative x squared. Negative times 2x is negative 2x. Combine like terms. So we have negative x squared minus x minus 1 all over x minus 1, x plus 2. And that's a way to answer. Or you can take the negative out and do negative x squared plus x plus 1 over x minus 1, x plus 2. Alright, part C. So part C wants us to multiply. So we want to do f times g of x. So we have f of x, which is 1 over x plus 2, times g of x, which is x over x minus 1. And anytime you multiply them, you do not FOIL the bottom. Don't FOIL the bottom, just leave it as is. So we have 1 times x is x, and then don't do anything to the bottom. Just write it out, because that's not simplest form. Alright, last part, part D. Now we're dividing. So part D, we're dividing the two functions. And we have f of x, so 1 over x plus 2, over g of x, which is x over x minus 1. So remember, we don't divide fractions, we multiply by the reciprocal. So we have 1 over x plus 2 divided by x over x minus 1. Flip the second one. That leaves us with 1 over x plus 2 times x minus 1 over x. And again, you don't distribute the bottom. So we have 1 times x minus 1 is x minus 1. And then don't do anything to the bottom. Alright, example 4, difference quotient. Alright, so your first day of pre-cal, you are going to talk about the difference quotient again. It is very, very important, because the difference quotient, I don't want to get there yet. We'll just wait. You'll learn more about it when you get to pre-cal and trig. But for now, we're just going to practice with it. So the difference quotient is f of x plus h minus f of x minus a or over h. That's a formula. So the first thing we're doing is we're doing f of x plus h. So for every x we see, we're plugging in x plus h. Then we're going to subtract that by f of x and put that all over h. So if our function is 2x squared minus 3x, we want to plug that in to that formula. So we have f of x plus h. So what we're going to do is replace every x with x plus h. So that's 2 times x plus h squared minus 3 times x, which is x plus h. And then we want to subtract that by f of x. So let me highlight the parts we did and how they coincide to each other. So minus f of x, so f of x is 2x squared minus 3x. And then that's all over h. Alright, now you just simplify. You're going to be able to simplify this quite a lot. It's going to be pretty cool. So the first thing you want to do is multiply x plus h squared. And that's just x plus h times x plus h. So we have 2 times x plus h squared. So that's x squared plus 2xh plus h squared. And then we want to distribute the negative 3. So negative 3 times x is negative 3x. And then negative 3 times h is negative 3h. And then we have negative 2x squared plus 3x now, all over h. Yeah, these are really long problems. Now we need to distribute the 2. So we have 2x squared plus 4xh plus 2h squared minus 3x minus 3h minus 2x squared plus 3x all over h. Now we want to combine like terms. A lot of the times, most of the things are going to cancel out. So like this negative 3x, this negative 3x and this positive 3x, this negative 2x squared, this positive 2x squared, nothing else can cancel out. So all we have left is 4xh plus 2h squared minus 3h all over h. Now do you notice at the top they all have h in common? You have to take it out. So now we have 4x plus 2h minus 3 all over h, and then those h's actually cancel out. So we're left with 4x plus 2h minus 3. Now, if you're like really confused with what we did, I will try to, after the test, go over a few before we get into 3.3 and 3.4 and so on. Alright, and that's it. So part B. Part B wants us to do the difference quotient for f of x equals 4 over x. So I'm going to rewrite it. We have f of x equals 4 over x, and then our difference quotient is f of x plus h minus f of x over h. So for the first part, we're going to put x plus h for every h we have. So that's 4 over x, which is x plus h. Okay, that's it. So that's where we got that from. So all we did was just put x plus h for every x, and then we want to subtract f of x. So that's subtract f of x, which is 4 over x, and then that's all over h. So we need to simplify. That means we need to add the top. So x plus h, x plus h, x, and x. Now we have 4x over x times x plus h minus, distribute the 4, 4x plus 4h over x plus h. Now the top, we're going to combine like terms, but first we need to distribute this negative. So we're going to distribute the negative and put it all under one denominator. So we have 4x minus 4x plus 4h all over x plus h, all over h. So in the top, the 4x's cancel out, and we are left with 4h over x plus h over h. Let's write it so it looks normal. So we have 4h over x plus h divided by h. Let's multiply by the reciprocal. So 4h x plus h times 1 over h. We can cancel out the h's. So we have 4 times 1 is 4 over x times x plus h. Oh, I messed up. That is supposed to be a negative. When we distribute, that's supposed to be a negative 4h. So then we're left with negative 4h. So that's negative. And then that just becomes negative. Alright, we still have 3.2 to do, so I'm going to do it in the same video. Alright, so 3.2. Alright, so 3.2 is, since we're talking about functions, now we're talking about the graphical functions. So how to identify functions, we use the vertical line test. So you remember the vertical line test, you put the lines through, and if they repeat on top of each other, it's not. So for example, right here on circles, you see how all these x's are on top of each other? It's not a function. So a line is always a function, a parabola is always a function, circles are never functions. Alright, example 2, obtain information from a graph. So basically we're going to look at a graph and answer A through G. It's really great. So let f be the function whose graph is given in figure 15. The graph of f might represent the distance y that the bob of a pendulum is from it at rest position at time x. Negative values of y mean that the pendulum is to the left of the at rest position, and position values of y mean that the pendulum is to the right of the at rest position. None of that matters. The only thing that matters is A through G in this graph. So part A, it's asking for f of 0, f of 3 pi over 2, and f of 3 pi. So what that means is it's asking for f of 0, that means if x is 0, y is what? And then f of 3 pi over 2, if x is 3 pi over 2, y is what? And then for f of 3 pi, if x is 3 pi, y is what? So all we're going to do is just look for those x values. So when x is 0, y is 4. See it? When x is 0, y is 4. So f of 0 equals 4. Now we want to do the same thing for 3 pi over 2. So when x is 3 pi over 2, y is 0. So when we have f of 3 pi over 2, it equals 0. Now we want to look for it when x is 3 pi. So when x is 3 pi, y is negative 4. So f of 3 pi equals negative 4. That's it. Alright, part B. It wants to know the domain. So the domain are the x values. Only using this graph, x starts at 0 and ends at 4 pi. Sorry, I was getting onto the range and we're not done here yet. So if x starts at 0 and ends at 4 pi, the intervals are 0 to 4 pi. That's it. And then part C is the range, which are the y values. So go from lowest high value to highest high value. So y starts at negative 4 and ends at positive 4. So our our range is negative 4 to positive 4. Alright, part E is asking how many times the line y equals 2 intersect the graph. So y equals 2 is right here. How many times does it intercept the graph? 1, 2, 3, 4. So E is 4 times. Oh, I forgot D. I forgot to list the intercepts. Alright, so for D, my bad. For D, it just wants the intercepts. So where on this graph does it cross the y-axis and x-axis? So your x-intercepts are pi over 2, 0, 3 pi over 2, 0, 5 pi over 2, 0, and 7 pi over 2, 0. So basically it's where it touches the x-axis. And then your y-intercepts are where it touches the y-axis. There's only one of them, and that's 0, 4. Alright, now on to F. F wants to know if f of x equals negative 4, what's x? Because this is saying y is negative 4. If y is negative 4, what's x? Well, x is pi and 3 pi right here. So when we have f of pi, that equals negative 4, and when we have f of 3 pi, we get negative 4. And then G is asking us when y is greater than 0. So this is when y is greater than 0, what are all of the x's? So you want to do all the x's that are greater than 0. So that leaves us with 0, if you see it right here, 0, 4, because the y is greater than 0, so we use it. Pi over 2 because y is greater than 0, 3 pi over 2 because y is greater than 0, 5 pi over 2 because y is greater than 0, 7 pi over 2 because y is greater than 0, 4 pi, and 2 pi. So basically everything above that x-axis. So we're going to have to write an interval notation as a set. It's actually pretty cool. So that's 0 pi over 2 union with 3 pi over 2 to 5 pi over 2. And then we union that with 7 pi over 2 to 4 pi. Alright, last example. How many minutes are we on this thing? 30? Wow. Alright, so last example, and then we are done. Alright, so average cost function. So the average cost per computer of manufacturing X computers per given day is given by the function, said function. Determine the average cost of manufacturing 30 computers a day, 40 computers in a day, and 50 computers in a day. So it tells us that X is the amount of computers per day. So all we're going to do is just plug in X for each A, B, and C. So A, X is 30. So all you do is plug in 30. So C of 30 equals 0.56 times 30 squared minus 34.39 times 30 plus 1,112.57 plus 20,000 over 30. And from here, you're just going to simplify it all. Be careful with your calculator. So we do 30 squared times 0.56, and we are left with 504. 34.39 times 30 is 1,031.7. Then we have to add that to 1,012.57, and then we do 20,000 divided by 30, and since we have all these decimals here, just work with decimals. So it's 666.667. Ooh. Now we just add them all up, so we get C of 30 equals $1,351.54. So the cost of making 30 computers a day is just over $1,300. Now we need to do the same thing for B and C. So B, X is 40, so we have C of 40 equals 0.56 times 40 squared minus 34.39 times 40 plus 1,012.57 plus 20,000 over 40. Alright, so we do 40 squared times 0.56, that's 896, minus 1,375.6 plus the 1212.57, and then plus 20,000 divided by 40 goes in perfectly to 500. And you just add them all up with your calculator, and we get $1,232.97. Alright, part C. X is 50, so doing the same exact thing except putting in for 50. So we have C of 50 equals 0.56 times 50 squared minus 34.39 times 50 plus 1,212.57 plus 20,000 over 50. Alright, so we got 50 squared times 0.56, that leaves us with 1,400 minus 1,719.5 plus 1,212.57 plus 400. Add them all up, and we get $1,293.7.